All right, get ready because today we're going to dive into something totally weird. It's these objects in space that can't seem to decide if they're asteroids or comets. Like, imagine a centaur in space. Not the mythical creature, but something just as strange.
Yeah, these centaurs, that's what astronomers call them. They really kind of blur the lines, They're out there in the outer solar system, just hanging out between Jupiter and Neptune, and they're giving us a whole new way of thinking about how our solar system actually works.
And the one we're really focused on today is Chiron. It's been causing a lot of buzz because of some awesome new discoveries from the James Webb Space Telescope, JWST. We've got tons of new research and articles about Chiron's surface and all the stuff swirling around it.
What's really cool is that we're getting a glimpse into the early solar system, like billions of years ago. Centaurs are like time capsules from way back then. And Chiron, because it's active, meaning it releases gas and dust, like a comet, lets us study both its surface and all the stuff it's throwing out. Most centaurs are way quieter, so Chiron's like a treasure trove of information.
So why all the excitement about centaurs? Why are astronomers so into them, especially compared to like a regular asteroid or comet?
Think of it this way. Most asteroids and comets have changed a lot over time because of the sun's heat and all kinds of other stuff in space. But centaurs, way out there in the deep freeze, they've basically stayed the same. Studying them is like looking back in time at the stuff that made our solar system.
So they're like a cosmic recipe book, and by studying Chiron, we can figure out what went into making our solar system.
Exactly. And Chiron being active adds a whole other layer to this. By looking at the gases it releases, we can learn about the temperatures and pressures from when it formed. It's like getting a chemical fingerprint of the early solar system.
Okay, let's get to the good stuff, the JWST discoveries. What did scientists find on Chiron that's got them so hyped?
The JWST found frozen carbon dioxide and carbon monoxide on Chiron's surface, which is pretty normal for icy stuff in the outer solar system. But here's the crazy part. They also found carbon dioxide and methane gas in its coma. That's the fuzzy cloud around the centaur.
A gassy centaur. Huh. That's not something you hear every day.
Not at all. It's the first time we've seen these gases in a centaur this far from the sun. It's about 20 times farther out than Earth. This discovery really changes how we think about what's possible out there.
Okay, gotta ask. Why should we be interested in ice and gas on something so far away? What's in it for us down here on Earth?
I know it sounds like just random space stuff, but it actually tells us about some really big questions. Like, it gives us a peek into what our solar system was made of way back when. These ices and gases might be leftovers from the cloud that formed our sun and planets.
So by studying Chiron, we're actually studying our own origins.
Exactly. And on top of that, seeing how Chiron changes over time, especially with the sun's heat affecting it, helps us understand how these objects evolve. It's like watching a super slow-motion cosmic cooking show. We get to see how the ingredients combine and change over billions of years.
I read that Chiron is kind of a weirdo, even for a centaur. What makes it so different?
Yeah, a lot of articles call it the rebel of the centaur family. It's got these unpredictable bursts of activity, like it suddenly wakes up and decides to put on a show. This comet-like behavior has had scientists scratching their heads for decades. Most centaurs are way more chill, but Chiron likes to keep us guessing.
A little dramatic, huh? What else makes Chiron stand out?
Well, it's got rings, which are super rare for centaurs. Picture a thin disk of stuff, probably dust and ice, orbiting Chiron. Some people even think there might be a whole bunch of debris orbiting it, left over from collisions or from those gassy outbursts we were talking about.
So not only is it active and putting on a show, but it might even have its own little posse. Chiron really knows how to make an entrance. But here's the big question. Do those new ice and gas discoveries from JWST explain any of Chiron's oddball behavior?
That's the million-dollar question. Scientists are working on putting the pieces together. The methane gas discovery is particularly interesting.
What's so special about methane?
Well, it seems like this methane gas is coming from a certain spot on Chiron's surface that's always getting blasted by the sun's heat. Think about ice cubes melting on a hot day. They shrink without turning into water. That's sublimation. The ice goes straight to gas. We think something similar is happening with the methane ice on Chiron, and this sublimation might be what's causing those dramatic outbursts.
So the sun's heat is basically making Chiron act up, causing it to release those bursts of gas. That's fascinating.
And what's even weirder is that every active centaur that JWST has looked at seems to have its own unique mix of gases and behaviors.
So they're all like snowflakes. Kind of makes things more complicated, huh?
It does. At first glance, they all seem like a bunch of random weirdos.
Yeah.
But there's got to be something connecting all these unique behaviors. something that explains why they're all acting up in the first place.
Any theories about what that might be?
Scientists are trying to crack that code. One idea is that it's all about what kind of ice each centaur has.
Yeah.
Different types of ice might sublimate at different rates, or under different conditions. That could explain why we're seeing all these variations.
So it's not just the sun's heat, but also what each centaur is made of.
Exactly. It's like a big recipe with different ingredients.
Yeah.
The centaur's composition, how far it is from the sun, how it rotates, even past collisions it might have had.
Seems like we need a lot more data to figure all this out.
Absolutely. And that's where JWST is so amazing. Its ability to pick up these faint signals of gas and ice, even in these super distant objects, is a total game changer.
Okay, let's switch gears for a sec and go back to Chiron's journey through the solar system. We mentioned how it got kicked out of the trans-Neptunian objects, those icy guys hanging out past Neptune. What does that tell us about where Chiron's been and what's in store for it in the future?
Imagine a little boat being tossed around by the waves from bigger ships. That's kind of like what's happening to Chiron because of the giant planets. Its orbit is chaotic, meaning it's getting pulled around by the gravity of Jupiter, Saturn, Uranus, and Neptune.
So Chiron's been on a wild ride.
Totally. And to make things even more crazy, Chiron's always losing a little bit of its mass as it releases gas and dust. That mass loss, plus all the gravitational pugging from the giant planets, could really change its orbit over time.
So we can't really predict where Chiron will end up.
Nope, not for sure. It might end up closer to the sun, becoming what we call a Jupiter family comet, or it could get flung back out to the edge of the solar system.
What would it look like from Earth if it became one of those Jupiter family comets?
Well, if Chiron gets close enough to the sun, the heat would make way more of its ice sublimate, which would create a way bigger and brighter coma. It might even be visible to the naked eye from Earth, like a bright fuzzy star.
Wow, a potential celestial showstopper, huh? Something to look forward to, even if it's millions of years away.
Exactly. And it shows us that our solar system is always changing. These objects are constantly on the move, their orbits shifting over time. It's like a giant cosmic dance.
It's crazy to think that something like a centaur could tell us so much about how our solar system formed and how it's changing. What are some of the other big questions that scientists hope to answer by studying centaurs?
One of the big mysteries is where these objects came from. Did they form where we see them now, or were they scattered inward from the outer solar system? Maybe even from the Oort cloud.
And how do we figure that out?
By looking at what they're made of. For example, certain ices and gases can tell us about the temperatures and pressures they experienced when they were forming. It's like a cosmic detective story.
So by analyzing the chemical makeup of these centaurs, we can get clues about where they were born and how they ended up where they are now.
Exactly. And by looking at their orbits, we can learn about how they've interacted with the giant planets over billions of years.
It's like these centaurs are trying to tell us a story, but we need to learn their language to understand it.
That's a great way to put it. And with each new observation, we're getting better at deciphering their language and putting together the history of our solar system.
This has been an awesome deep dive. We've learned about Chiron's quirks, the groundbreaking discoveries from JWST, and what it all means for how we understand the solar system. What are some of the key takeaways you'd like our listeners to remember from this deep dive into the world of centaurs?
You know what really struck me is how much action is going on in the outer solar system. I used to think it was just this empty, frozen wasteland. But the centaurs are proving that's totally wrong.
Yeah, for a long time we were all about the planets, like they were the stars of the show. But now we're realizing that the supporting cast is just as interesting.
It's like finding out that the side characters in your favorite book have their own crazy adventures.
Haha, that's a good one. And I think this change in perspective means a lot, even beyond our own little solar system. If we're finding so much variety and weird stuff right here in our neighborhood, just imagine what's out there around other stars. It's mind-blowing. Okay, before we finish up, I have one more question that's been bugging me. You said that studying centaurs can help us understand how our solar system got started and how it's changed. What are some of the things we're actually learning?
Well, one of the big puzzles is figuring out where these centaurs came from. Like, did they form right where we see them now, or were they pushed in from the outer edges of the solar system? Maybe even from the Oort cloud.
And how do we know for sure?
It's all about what they're made of. For example, if we find certain types of ice or gas, it can tell us about the temperatures and pressures they went through when they were first forming. It's like a cosmic crime scene investigation.
So by looking at the chemical makeup of these centaurs, we can get clues about where they were born and how they got to where they are now.
Exactly. And by studying their orbits, we can learn about how they've interacted with the big planets over billions of years.
It's almost like these centaurs are telling us a story, but we have to learn their language to understand it.
That's a great way to think about it. And the more we observe them, the better we get at deciphering their language and piecing together the history of our solar system.
This has been an incredible deep dive. We've learned about Chiron's quirks, the mind-blowing discoveries from JWST, and what it all means for how we see the solar system. Any parting words for our listeners?
I think the biggest lesson here is that we should never stop being curious. The universe is full of surprises, and the more we explore, the more we realize how much we don't know. Objects like Chiron remind us that there's always something new to find, something that can change how we think and make us see the universe in a whole new way.
Well said. And on that note, we'll leave you with this thought. If every active centaur that JWST studies is full of surprises, what does that tell us about how vast and complex space really is? There's so much out there waiting to be explored. Who knows what incredible discoveries are just around the corner? So keep looking up, keep asking questions, and never stop being amazed by the universe.